All right, welcome back to day number 2 of the Pythagorean Theorem. We're going to review again the basics of the Pythagorean Theorem, do some more practice, and take a look at why it works and how we can use what's called the converse to tell whether or not triangles are right triangles. So I'm ready to go. I got my pen, I got my highlighter, I got my calculator here ready to go. So if you would also gather all of the things that you need for this lesson, and we'll go ahead and get started. All right, so the Pythagorean theorem states that, in simple formula terms, a squared plus b squared equals c squared. What that means is that a, b, and c are the sides of a right triangle. This works only for right triangles, by the way. It says that the legs of the right triangle, touch the right angle. So we're going to go over here to this picture in a minute. The legs must be labeled A and B in the formula. And the hypotenuse is the side opposite from the right angle, and the hypotenuse must be labeled C. Okay, so let's come over here to our picture. I'm highlighting the hypotenuse every single time I do this. I know it's a hypotenuse because it is across from the right angle. And it doesn't matter which one of these is A and B, they are interchangeable. Okay. So the Pythagorean theorem is used when we know we have the lengths of two sides of a right triangle and we want to find the missing third side. So let's go ahead and put that to use in these examples here. If I have a triangle and A is 6, I don't know what B is, and C is 10, how can I find the missing side? We're just going to put these numbers into the formula A squared plus B squared equals C squared. So 6 squared plus B squared equals 10 squared. Please ignore the banging. I don't know what my husband is doing. Okay, because I'm looking for a side, I'm going to be subtracting. So I'm going to subtract 36 from both sides to get B squared equals 64. The last step, take the square root of 64, and I can find that the missing side is 8. Okay. Next example. I have an A side, I have a B side, and I'm looking for the C side. When I'm looking for the hypotenuse, I know I'm simply going to be adding. Okay, so I'm going to go 5 squared plus 12 squared equals C squared. 25 plus 144. 169. Let's take the square root of both sides. And that's going to give us 13. And the last one, I don't know what A is, but I have a B and a C. Because I'm looking for a side, I know I'm going to be doing a subtraction step here. Okay, A squared plus 24 squared equals 25 squared. So A squared plus 24 times 24, 576. 25 squared, 625. Here comes that subtraction step. So A squared equals 49. Last step, take the square root of both sides, and our answer is 7. So that's how we use the Pythagorean theorem to find the missing side of a right triangle. Okay, we could also use the Pythagorean theorem to determine if a triangle in fact is a right triangle. Okay, if a triangle is a right triangle, we go through the steps and we call this the converse of the Pythagorean theorem. I'm going to start to abbreviate for you guys. The converse says if the formula a squared plus b squared equals c squared is true, then we know that we have a right triangle. So if we look at a set of numbers and we plug that in to the Pythagorean theorem and it comes out to be true, we know our triangle is a right triangle. Okay, a set of three numbers that can be used to identify a right triangle are called Pythagorean triplets. These are whole numbers that make a right triangle. The most familiar of these is the set of numbers 3, 4, 5. This is the most famous Pythagorean triplet, and here's why it works. 3 squared plus 4 squared, does that equal 5 squared? Well, 3 squared is 9, 4 squared is 16, and 5 squared is 25. 9 plus 16 equals 25, so yes, that is a right triangle. And again, that's the most famous of all Pythagorean triplets. Let's see if 6, 7, and 8 works. 3, 4, and 5 works. Why not 6, 7, and 8? Well, let's see. 6 squared plus 7 squared, does that equal 8 squared? So 6 squared is 36, 7 squared is 49, 8 squared is 64. 36 plus 49 is going to equal 85, and 85 does not equal 64, so this is not a Pythagorean triplet. Okay, we're going to do one more that is a yes. We're not going to go through all of these. Let's do 9 squared plus 12 squared. Does that equal 15 squared? So 9 squared is 81, 12 squared is 144, 15 squared is 225. Does 81 and 144 equal 225? In fact, yes it does. So this is another Pythagorean triplet. There is a long list of Pythagorean triplets that you can find and become familiar with, which is a very good thing to do. But if you just remember 3, 4, 5, you're good to go. All right, let's turn the page. Yesterday, I hinted a little bit about this particular drawing about the Pythagorean theorem. So let's go ahead and use that 3, 4, 5 Pythagorean triplet. So if one side is 3, one side is 4, and the hypotenuse is 5, how does this work? The small square right here has a side length of 3. The medium square has a side length of 4, and the large square has a side length of 5. So if we squared these numbers, we would get the area inside each one of these boxes. So if I said 3 times 3, I'm going to get 9. Said 4 times 4, I'm going to get 16. And 5 times 5, I'm going to get 25. So 9 squared is the small box, 16 squared is the middle box, and 25 squared is the big box. Okay, the area of the small square plus the area of the medium square, 9 plus 16, does that equal the length of the big square? And yes, in fact, it does. So the two small squares together have the same area as the large square. This is actually a proof of the Pythagorean theorem. All right, what we're going to do one more time is we're going to practice finding missing lengths. And I want you to follow the steps that I give you and don't miss any. So the first step, where's the right angle? Identify where's the hypotenuse. So here's my highlighter. I now know that that is the hypotenuse of the missing side. I can call these A or B, it doesn't matter. And now I can write the formula. I'm missing the hypotenuse, so I know that I'm just going to be going through an adding equation. So 8 squared plus 12 squared equals c squared. So 64. 12 times 12 is 144. Okay, I'm running out of room on my paper. So I'm going to get 208 is equal to c squared. The last step is to simply take the square root, and I'm rounding my answer to the nearest tenth, actually. 14.4 is C. Come back to the triangle. Is it the longest side? And yes, it is. Okay, next example. Grabbing my highlighter. Here's the right angle. There's the hypotenuse. Now I'm ready to label the sides. Don't skip this step because I promise you this is where all the mistakes come from. So now I can say 5 squared plus b squared equals 15 squared. So 25 plus b squared equals 225. I'm going to subtract, so here's that subtraction step. B squared equals 200. We're going to take the square root of 200, and our answer is 14.1. Bring it back to the triangle. Does that still keep the hypotenuse along the side? And the answer is yes. All right, I'm going to skip this one. I want to go down here and talk about this converse activity. If I give you a set of numbers and I ask you whether or not this is a right triangle, the first thing you really need to do is figure out which one of these numbers represents the hypotenuse. So you're going to go through this list and you're going to pick out the biggest number. The biggest number is 30. That has to be C. So now I can say 10 squared plus 20 squared, does that equal 30 squared? Okay. So 100 plus 400, does that equal 900? And the answer is no. This is not a right triangle. Okay, let's try the next one. 9, 12, and 15. 15 is the longest side, so I know that that's the hypotenuse. 9 squared plus 12 squared, does that equal 15 squared? So 81 plus 12 times 12, 144. 15 squared, 225. Add these together. Cool. 225. So the answer here is yes. This is a right triangle. Okay, at this point, I'm going to ask you to work on the practice problems on the next page on your own. So you can pause the video, okay, and in a few minutes, I will start to show you the answers. So I'm going to show the answers in a couple stages. So there in the classroom, you can be working, and who's ever with you can reveal the answers as you're working. So you can pause the video now. All right, here I come with the first set of questions. There's the first 3. So we'll go about it that way. You can check your answers to make sure you're on track. Okay, here come the next set of 3. And here comes the third set. Here's where you're deciding yes or no. And finally, the last set of answers.